So today our topic is Hamiltonian circuit. So first we have to know what is Hamiltonian cycle. So a graph with vertices V and edges E are given, then we have to construct an Hamiltonian cycle using backtracking method. What is Hamiltonian cycle? If the starting position and the end position of a graph is same, then this is called Hamiltonian cycle. So if the starting position of the graph is this position and we have to traverse all the vertices exactly one, and then return back to the starting position, then it is called the Hamiltonian cycle. Okay, so using which method? Using backtracking method. And if it is a Hamiltonian cycle, then it is called also the Hamiltonian circuit. Otherwise, it is a non-Hamiltonian cycle. If Hamiltonian cycle form inside the graph, that means if all the vertices are traversed and the starting position and ending position is also reached are same, then it is Hamiltonian cycle. Otherwise, it is non-Hamiltonian cycle. Okay. So let's take an example. So this is a graph given. There are 8 number of vertices, 1, 2, 3, 4, 5, 6, 7 and 8. 8 vertices. So we have to traverse all vertices once and non-repetitive manner, and we have to starting from these vertices and ends in these vertices. Okay, so at first we have to start our vertices with 1. We may take vertices 2, we may take 3, 4, 5, 6, 7, 8, but suppose we take here 1. Okay, so we have to take our vertex with 1. So the root vertex is, this vertex is known as the root vertex. Root vertex is 1. So our root vertex is 1. So now we have to check the adjacent of 1. So what are the adjacent of 1? 2, 3 and 7. Adjacents of 1 are 2, 3 and 7. So now we have to check the adjacent of 1. The adjacent of 1 are 2, 3, 7. So we have to this one 2, 3 and 7. Now again we have to check the adjacent of 2. So what is the adjacent 2 to 1 to 2? Then what is the adjacent of 2? 2 is 3 and 1, but 1 is already visited na. So we have to write only adjacent of 2, 1 and 3, but 1 is already visited. So we have to ignore 1. So we have to ignore the 1. Now from 3, where we reach 3. From 3, what are the adjacent? From 3, the adjacent are 4, 6 and 1. 3, 4, 6 and 1. Sorry, 4, 6 and 2. 4, 6 and 2. So from 3, we have to 6 and 4. 2 is already here. So 6 and 4. Okay. So now from this to this path we have to traverse all path. Okay, exactly once. Now let's me rub this. So from the graph we see, if we go 1 to 2, then 2 to 3, then 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 2, 8 to 2. But 2 we have to return from 1 na. So 2 to 1, the path is already traversed here, so it is not a path. Okay, then again we look in the graph that if we cover this path 1 to 3, then 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, then 8 to 2, then 2 to 1, then this is a Hamiltonian cycle, because the starting point and ending point is 1 and we traverse all the vertices. First we traverse 1, 2, 3, then 4, then 5, then 6, then 7, then 8, then 2, then return back to 1. So this is a Hamiltonian cycle. Okay, so from here we write this part. So now here we use the all process. We overcome the all outcomes. We will see the all outcomes now. So 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9, 8 to 2. So in this 1 to 3 to 4 to 5 to 6 to 7 to 8, then 2 to 8 to 2, but this is not, because we have to reach in one position, so this path is not granted. Then 7 to, there is another path, 7 to 1. Yeah, now the starting point and ending point are same, but 8 number vertex, but this number vertex is not visited because the path is our this path. 1 2 3 4 5 6 7 and then 1. That means 1 2 3 4 5 6 7 then 1. This path is not visited, so this is also not granted. Okay, so this may be also an case that all, maybe the initial and the last position is same, but not all the vertices are granted, so we have to cover the all condition. Okay, so we have to backtrack all the outcomes. All outcomes are here given, that 1 2 3 3, the adjacent of 3 are 3 to 2 3 to 6 3 to 4, all the, but the solution is what we get: 1 to 3 3 to 4 4 to 5 5 to 6 6 to 7 7 to 8 8 to 2 and 2 to 1. So the required solution is we get 1 to 3 3 to 4 4 to 5 5 to 6 6 to 7 7 to 8 8 to 2 and 2 to 1. Now 1 we get the 1 now, but 1 is the starting point also, and all the vertices are covered here. Look, 1 3 4 5 6 7 8 2 then 1, all the vertices are covered also, so this is our solution path. So our solution path is 1 3 4 5 6 7 1 3 4 5 6 7 8 to 1. The starting point is equal to end point, so this is the our solution path. So this is a Hamiltonian cycle, and our Hamiltonian graph is, if what is I said before, if there is a Hamiltonian path, if there is a Hamiltonian path, then it is a Hamiltonian graph. So the Hamiltonian graph is 1 to 3 3 to 4 4 to 5 5 to 6 6 to 7 7 to 8 8 to 2 and 2 to 1. I hope you understand. Thank you.